Hello, welcome to our channel for R programming. In this video, we will show how to do power analysis for t-test in R. So first of all, we will introduce what is power analysis. So power analysis is a kind of analysis that lets you to determine what's the sample size you will require to make an experimental design. And for this sample size, usually the minimum sample size required to detect an effect of a given size and with a given degree of confidence and the significance of level. So the degrees of confidence here, which is 1 minus type 2 error. So type 2 error is if the effect is significant but you did not reject. So this is type 2 error. So 1 minus type 2 error also we can call this is the power of analysis. So this is the power of the test. So this is what we call power analysis. But at the same time, we want to minimize, or at least we want to ensure that the type 1 error is no less than a significant level. So type 1 error is actually the effect is not present, but you say the test is significant and you reject the null hypothesis. So this is type 1 error. So we have to minimize type 1 error, and usually this level is 0.05. So there are 4 quantities in power analysis: sample size, significance level, usually 0.05, and the power usually 0.8, 0.9, and effect size. So we know 3 of these 4. Then we can find the other one. So this is a figure showing the relationship between these 4 quantities. So the power is 1 minus type 2 error, and significance level is type 1 error. So next we will show how to implement power analysis in R programming. Because we can use pwr package in R for the power analysis. And this package includes many functions for different kinds of statistical analysis. And for the different type of analysis, experimental design, the effect calculation is different. So here we just talk about a very simple case for the power analysis. This is the t-test. Actually, these are 2 sample t-test compare the difference of their mean. So in this kind of test, we will use pwr.t.test from power package. And we can set n, d is the effect size, n is the sample size, and the significance level and the power. So very clear for these 4 items. And alternative is for the one-sided test or two-sided test. So here usually is 2-sided test is to test the two-sided test means the null hypothesis is 2 mean or 2 population, 2 sample size are the same. So this is an alternative test. So next we look at an example. So quite a long text. So experiment involving cell phone use to driving reaction time assumes that you will be using a 2-tailed independent sample t-test to compare the mean reaction time for the participants in cell phone condition with the mean reaction time for participants driving an incumbent. So let's assume that you know from past experience that the reaction time has a standard deviation of 1.25 seconds. Also, suppose that 1 second difference in reaction time is considered an important difference. So you would therefore like to conduct a study in which you are able to detect an effect size of D equals 1 minus 1.25 equals 0.8 or larger. So here we can see for the t-test, independent t-test compared to mean, if we want to test a difference of mean as large as, for example, 1 here, and we know the pooled standard deviation from experience. So we just divide this difference of the mean by this standard deviation. So this is effect size in t-test. And additionally, you want to be 90% sure to detect such a difference if it exists, and 95% sure that you won't declare a difference to be significant when it's actually due to random variability. And how many participants will you need in your study? So here, the 90% is the power, or say we are 90% confident that we can find this effect. So this is the 1 minus type 2 error. And at the same time, we want to be sure that the 95% significance level, we will not make type 1 error larger than 0.05. So this is the trade-off. So we know these three, then can define the minimum sample size required to detect such effect in t-test. So next we just show how to use this function from Power Package. Actually, it's quite simple. We just load library pwr, then pwr.t.test. Just fill in the effect 0.8 and significance level 0.05 and the power 0.9. Type is two sample. Alternative also two-sided. So here type is two sample because we have two sample. Compare the mean. So here is two sample. Just run, and the result will show. The result will show all these four items. So here n is 33.8, and the notice n is number in each group because we use two sample. So the result of this example is suggests that you need 34 participants in each group. So actually the total sample size is 68 participants. This is the minimum you require to detect an effect size of 0.8. So here effect size 0.8, which means you know the standard deviation from past experience is 1.25, and you want to detect the difference between two mean as large as 1 second. So the division of these two is 0.8. And you with 90% certainty, this means you have 90% the chance to find this effect, to reject the null hypothesis that the two samples are equal. And simultaneously, you have no more than 5% chance of erroneously concluding that a difference exists. So this is 95%. Yeah, you keep the type 1 error as lower as less than 0.05, right? Thanks for watching.